We are ready to begin our tech talk today on top-down versus bottom-up modeling in NX CAD. Your questions will be answered live at the end, but please go ahead and enter them into the chat as they come up if you would prefer. Our presenter today is Bilal, who is located in our Cincinnati office. He is an NX CAD application engineer, a University of Cincinnati Mechanical Engineering Technology graduate, recognized as a 2024 MET Graduate of the Year nominee, with expertise in manufacturing, design, performance motorsport, and 3D printing. He is now focusing on opportunities in CAD applications engineering. Welcome, Bilal. The Tech Talk is now yours.
Thank you very much, Amanda, and welcome everyone to the Tech Talk. So to get us right up and going, my name is Mohammed Balsaid, as Amanda said, and today's agenda, we're going to be covering what is top-down modeling and what is bottom-up modeling, and how are they different, and which one is better, essentially. Now, the agenda for today, what is top-down and what is bottom-up modeling? So what are they? Where do we use them? Why would you choose one over the other? And then, of course, the hot question, which is, which one is better? And then, of course, how do I use them? Now, a quick introduction to what is top-down modeling. Top-down modeling starts with a master model or a skeleton that defines the high-level structure of the product. And that's where designers can then create reference geometry, like you can lay out sketches, planes, envelopes, or control surfaces that downstream parts and assemblies depend on. Now, the key features of top-down modeling is that it starts on the system level or product level geometry. The master model controls the dimensions, positioning, and relationships, and the changes propagate down the hierarchy. And it typically uses context-sensitive or in-context modeling. Now, can anyone give me an example of top-down modeling? That's all right. I took my telepathic coffee today, and so now I have the amazing powers of telepathy. So I can read your mind, and yeah, an example of that would be modeling automotive components, such as like, your mounting, your bodywork, your electrical CAD, or even your chassis. Like all those components can be used to kind of drive each other. Now, bottom-up modeling is where it involves designing individual components independently and then putting them into a final product. So parts are created in isolation and then only integrated during assembly, right? So the key feature of this is that each part is a standalone model, and components are later inserted and mated in an assembly environment, and this will allow you to emphasize the reusability of that part. And also, assembly constraints are used to position those parts, usually with top-down. Some people like to believe, or in fact, some people do this, where you would just use your model driving off of another model to then keep those two constrained together. That's not our recommended approach. I would still recommend using your assembly constraints to position them appropriately, because if you change one piece of the model or if you change something in a subassembly, things might move to where you either can't get to them or just completely out of the model or where you need them to be. So, of course, using my telepathic powers, an example of this, can anyone think of an example of bottom-up modeling, something that you guys use very often? That's right. Off-the-shelf parts like bearings, fasteners, or standard gears, which are designed or imported first and then assembled into your machine without needing to change the components themselves. I'm not always going to, model myself my standard quarter 20. I'm going to get that off of McMaster-Carr, or if I have a repository fasteners in my reuse library, then I would use that. So why would you choose one over the other? Well, you would want to choose top-down when you have a complex geometry with tight tolerances between parts. The final form of the components depend on the overall layout, and of course, you want full parametric control over the entire assembly. And of course, you would choose top-down when you're working with a highly integrated system. So for example, automotive interiors, even turbine engines. Where would you use, or why would you choose bottom-up? Well, you would choose bottom-up when you're reusing standard parts. So like your bolts, bearings, motors, etc. Parts that can be independently developed or outsourced. So let's say if I'm working at a company that, makes performance automotive, or let's say I'm in an automotive manufacturer, and I want to use off-the-shelf parts. Let's say I wanted to use off-the-shelf dampers from, a third party or a partner of ours. So rather than modeling that damper myself, I can have this damper modeled or take the model and then put it into my CAD. So parts can be independently developed or outsourced. And then, of course, bottom up if you want easier collaboration across different teams. And I'll get a little bit more into that as well. And of course, you prioritize modularity or large state design changes, or large stage design changes, my apologies. Now, where do they shine? Well, I've put this down into a little table where, you've got different industries and applications. You've got your best approach in quotation marks, because that's what we're going to discuss in the next slide. And of course, why you would want to choose this particular one. So for automotive body design, you would want to choose top down. Why? Because you've got integrated surfaces with tight packaging. With consumer electronics, you might want to also still do top down, because the tight form factors and shared enclosures might be one reason. You can also choose to do bottom up. It really depends on what your needs are. You also might want to use bottom up with machinery and equipment, where you have your standard components and modular assemblies. So let's say if you wanted to put in a vise into your, let's say into your machine simulation for CAM, right? You're not going to build a vise by yourself. You're just going to kind of import and put it in there. And then, of course, tooling and fixtures. This is one where it depends on what you need to do. If you're doing something very complex, like, for example, working on the next best, commercial turbine engine, then you might want to do top down, because certain things might be held or, worked with a certain way. Or you might even use bottom up for, simple things like, just importing a vise, certain fasteners, or just, standard parts that you have. And of course, the reason for that is repeatability and part reuse. Now, aircraft design, you would want to use top down, because, well, you need that control over large systems. And so this is just a couple examples of where would they shine, or which approach would shine where and why. Now, the main question, is one better than the other? Well, as a lot of you may guess, no. It depends on your project goals, right? In reality, most professional workflows use a hybrid approach, which will leverage the strengths of both. So for top down, that strength is that core layout and interface. And for bottom up, it's that it's to insert pre-designed and reusable parts. So for example, my suspension damper or fasteners in general, or bearings, standard parts, right? So here is a quick comparison table of like top down, what that's good for, and bottom up, what that's good for. So bottom up is great for your modular and independent components. It's strong in part reuse and flexibility. And of course, it's best for distributed collaboration. Whereas your top down is great for integrated and controlled designs. It's got some strong parametric updates. And of course, it's best for centralized teams. Now, what do I mean by those centralized teams? Well, it means a team structure where most or all of the design and development work is done in a single location or tightly controlled group, often sharing the same CAD environment, database, or design rules. Now, here's a quick, in quotation marks, quick comparison of top-down modeling and bottom-up modeling, like the feature and aspects, and like a nice little comparison between the two. Now, I'm not going to go through this entire table, but I am going to highlight some key parts that I would like to kind of emphasize. First one is the approach. With top-down modeling, you would have your system level first, and then your parts are developed from a global structure. With bottom-up, you would start with the component level first, and then assembled into a product, right? So with top-down, you start in the assembly space, or you start with the idea of the assembly, and then you make your components from there. With bottom-up, you start from the components, and then you assemble them all together, and then you make the changes that you need. Next is flexibility is one of the things that I want to highlight, which is top down is there's high flexibility for internal changes, but low for independent changes, right? And bottom up modeling, it's high for interchangeable parts, but low for large scale edits. What do I mean by that? Well, if let's say a certain hole or a cutout or a bore for a bearing is a little too big, well, now I have to go into that component model and then change that, or do whatever I need to do. But let's say if I have a driving off of the bearing already, then I don't have to do much other than maybe replace the bearing part, and then it'll then automatically adjust that bore as well. Now the speed, this is important. For top-down modeling, it will be slower in the early phase. Why? Because it requires planning of that master model. And with bottom-up, it's usually faster because parts can be developed in parallel, as I mentioned. The late phase speed is where top-down modeling becomes faster because the changes update automatically across the model. If you make one change and it's driving other components, you don't have to go into those components individually and then change them appropriately. You just change one thing, and because they're driving each other, they change automatically. And then, of course, with bottom-up modeling, the late phase speed is going to be slower because it may require manual updates and checks. Now, I don't necessarily like mentioning this, but there is a learning curve, as some people would say, to top-down modeling. And they would say it's higher than bottom-up, right? Because it requires that planning and reference control. Because you can really make your assembly very messy if you start referencing things that really shouldn't be referenced together. You can also end up with something called a circular dependency, where kind of like a snake that's trying to eat its own tail, you kind of create an issue there, and then that may cause your assembly structure to, crash on. And then with bottom-up modeling, it's lower because it's more intuitive. You have different parts, you need to put them together like Lego, and it's less dependent on external geometry. Now, how do I do bottom-up modeling? Well, as some of you may have guessed, the first step is to create your part file. The second one would be to create your geometry, or your model, essentially. Step 3 would be then to save the file. And then step 4 would be added to the assembly. And of course, step 5 is to appropriately constrain your assembly. Simple enough. Now, what are the steps for top-down modeling? Well, some of you may guess that, yes, step 1 is to create your NX part file. Step 2 would be to create your geometry. And from my telepathy, I also hear that, okay, step 3 would then just be to, create other bodies using your pre-existing geometry as references. Well, actually, that's the wrong method. Now, why is it the incorrect method? Well, because creating bodies within the same part file using other bodies as reference will create dependencies that may cause issues later on. For example, if I try to isolate or work on the part in another window, or even just open the part individually, it'll pull up those other reference bodies into my part files too. So when you're trying to open up one component of your assembly, you're now pulling in multiple parts of the assembly that you didn't want in there in the first place. And of course, when you go import that into either a different assembly or, whatever your use case might be, you're then going to have different parts and pieces that you will end up hiding because you can't get rid of them, unfortunately. Unfortunately, because they are dependent for your other model. So you have to be very careful. So what are the proper steps? Well, as you may have guessed, the first steps are the same, where you create, or the first step is the same, which is where you create your NX part file. Step 2, and this is very important, which is immediately go into your assembly tab and create a component. You don't need to select any objects because it's not a red star, and red star or red asterisk usually means it's required. In this case, it doesn't have one, so you don't need one. Step 3, very similar to our bottom up, where you just you make it your work part. So this is also another important piece where you make it your work part. And then, of course, you then start modeling it. And if necessary, you can then wave geometry link your references, right? And some people may say, if I'm not allowed to just kind of, like I did earlier, or as I was doing earlier, I can no longer select different pieces because it just won't let me. Well, I'll show you how to do that in a few upcoming slides. Of course, step 5 is to model your part however you want it. And then step 6, work on your displayed assembly unless you're trying to create a subassembly. So if you're trying to create a subassembly, you can then create another component, and you can repeat the steps from 2 to 6 to whatever you need. Now, when you save, NX will present to you a dialog box where you can individually name your new component and part files and save them to a location of your choice. It'll basically open up multiple different little tabs, or you can click on each of your model names or model files, and then you can then choose what to name them and where to put them individually. You can also put them in the same file location. It's just something that NX does just to ensure that, if you need that flexibility, you have it. Now, you may say, hey, wow, that's a lot of steps for something so simple. Why would I want to do this? Well, remember, speed in the early phase of the design will be slower, but you will make it all back in the late phase with the update structure. And frankly, this is the appropriate way of doing top-down modeling. Well, you may say, how do I reference these different parts in my assembly and what is wave geometry linker. So we'll do a short introduction into that, and I'll tell you how to reference those different parts. Well, wave geometry linker is a feature that allows you to associatively, or not, link geometry like bodies, faces, curves, or sketches from one part to another. So this means that if the source geometry is modified, the link geometry in the receiving part will also be updated. So it's a powerful tool for top-down design and manufacturing stage modeling, which streamlines the design process and ensures consistency across different parts of an assembly. So essentially, the wave geometry linker allows you to import your geometry, maintain associativity between the source and linked geometry, and control the direction of changes, which is usually one way from the master. So it's either going straight down, but you can also have it where it kind of branches out sideways, depending on your modeling structure or the model that you're trying to design. Now, where can you find it? Well, in your Assemblies tab, Interpart Links and Wave Geometry Linker. That's where you can find it, or you can just type Wave Geometry Linker in your command search. And if you need help finding it, I've recruited Bill Nye the Science Guy to show you exactly where. Now, when you click on that icon, this will open up a dialog box. And this is what that dialog box looks like, where we have, our red asterisk. In this case, I have composite curves, and each of the different functions in this dropdown will then have its own set of settings, where you can turn off associativity or turn it on. You can have making things context independent, which will then allow you to move things around while still maintaining that associativity. You can really do a lot of things. You may also see that we've got mirror body and routing object. Both of those are very useful, especially when you're doing, some electrical CAD, or mirror body if you're trying to balance something out, but you want it mirrored on a certain plane. Now, if you want more information on wave geometry, Brian Fisher, our senior NX CAD application engineer, did a tech talk on this a couple weeks ago, or in fact, I think a couple months ago, all about wave geometry and links and how they can enhance your design in NX CAD. He goes really in depth with this, and I would highly recommend watching this video. Now, what are other ways other than using wave geometry linker? Well, you can still use the include commands while sketching. So this is in your sketching environment. You go up in your home tab, you go to the right where it says include, and you can see you've got project curve, silhouette curve, intersection point, and add curves, as well as the main include function. And of course, when you first run this command, if you haven't done it before, your selection filter may be set to work part only, and that's just by default. What I would recommend you do is change it to entire assembly, because then that'll allow you to pick and choose different objects, and by objects I mean lines, faces, etc., from different components in your assemblies file. All right, well, time for a short demonstration. So I'm going to pull up my NX, and I'm going to show you how to do a very quick top-down assembly. So first things first, step one. In fact, I'm going to grab this little piece over here and move it over, because it is quite distracting and it's in the way. So I'm going to go to my Assemblies tab, New Component. If I had something I already wanted to add, I can also choose Add Component, but in this case, I'm going to go to New Component. And again, there's no red asterisk here, so I don't need to do anything. If I name my component here, it's still going to show up as Model 1, because the way how NX works is that when you save your part file, whatever you save its name as is what you're going to see in your assembly structure. So here, if I go to my assembly navigator, you can see it says Model 1, even if I had named it something like, top or bottom or whatever I wanted to call it. Now here in my Model 1, what's step 2? I have to go make this my work part. You can double click it, or you can right click it, and then I'm now able to work with it in context of my assembly. Now here, I'll just make a simple block. So I've got my block command over here. And I'll say OK. So now I have this 5 by 5 by 5 inch, just simple block. And let's say, that's it. That's all I wanted to do. I can make more edits. I can do whatever I want. Let's just assume that this is what I wanted to do. So now I can right click and then right click in open space and then work on displayed assembly, or I can double click my top down assembly file structure again. Now here I am back in my original assembly file. Now if I wanted to create another component, I can do that again. Create new component. Remember, I'm in the parent file now. I'm no longer in my modeling file. or in my component file, because if I was in my component file, it would then make it a subassembly, but I don't want it to be a subassembly, so I'm going to actually even name this to model 2-2. How about that? And even when I press OK, you'll notice that it just still says model 2, which is the default. Don't worry, that'll change when you save it. So go back into this, and now what I'm going to do is I'm going to show you how to use Wave Geometry Linker, and then in another instance, I'll show you how to use your include for your sketcher. So here, I'm going to click on Wave Geometry Linker, and as you can see, we've got different composite curves. I can have points, I can choose datums, sketches, faces, etc. In this case, I'm just going to choose a composite curve, and then select my curves that I want to choose, and you can see it allows me to do that from the space itself. I'm going to keep that associative. I can also choose to make it context independent, but in this case, I don't need to. I can choose different things. And of course, if I ever don't know what something is, I can always click on this question mark. It will then open up a website or open up a web page to Siemens documentation on how to use different things. Or you could click the F1 key. These are very, very useful, especially with the self-help nowadays. So I'm going to say OK. And now you might not be able to see it, but it's actually in there. There's my linked composite curve. And if I wanted to, I can now extrude something out of here. And just to make it different, I'm going to give it a draft of a little bit more than 2 degrees. Yeah, we'll give it an 11-degree draft. And that looks good to me. So now we have this piece over here. Now, when I go back and work on my displayed assembly, this is a separate body, and this is a separate body as well. Now, what happens if I come back into Model 1? And I'm going to go into my Part Navigator, and this is my Details tab. If you don't know much about the Details tab, or if this surprises you, go watch our Expressions Tech Talk that we actually did last month, and I'll talk about expressions and how every command in NX creates an expression. So here, I'm going to go from my Z height, I'm going to make that 3 inches, and I'm just going to hit Enter, and we see the moment I did that, it changed the other piece. Why? Because it's associatively linked to this initial body. Pretty cool. Now, I'm going to create another model. In fact, I'm going to go back into my displayed assembly, and I'm going to create another model based upon this face over here. And how do I do that from the sketcher without using Wave Geometry Link? Well, let's go explore that. I'm going to create a new component. We can call that Model 3. I'm in Model 3 now. And once I go into my sketch, I'll just choose a plane. Go choose my front plane, hit OK. And now, in my include, you can see I only have within work part only, so this is the default, but I can't click on anything. It doesn't let me. If I go and select entire assembly or within work part and components, if I'm working in a subassembly, then I'll be able to then select different pieces. So here I'll just choose this, 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 and this. Now what include does is that creates a reference geometry for you to use. If I wanted to use the actual or the direct lines itself, I can also choose project curves, which would then make it straight. Straight in the sense like non-reference geometry or non-reference lines. So I'm going to Control Z, and I'm going to show you how to do project curve, and that's what we're going to use for this one. Again, need to select my selection filter to entire assembly. And once you do this once and execute the command, it'll actually stay as your default or last use. So I've maintained that associativity. You might have seen that there was a box for associativity. I had that checked on. So now whenever I use this, or whenever I create an extrusion of this piece over here, I'm going to move this backwards a little bit and make it just a tad bit smaller. And we can create a draft this time the other way around. So slightly outwards. And I hit OK. Go back to my displayed assembly. And now, if I want to, I can go back to Model 1. Because I have maintained that associativity, it is going to change whatever is driving off of these two faces to the other pieces. Now, the thing about wave geometry and this associativity, one thing you want to make sure of is that you want your parts to be fully loaded. And we can discuss how to double check that. So here I'm going to make this 6. I'm going to hit Enter. And once I go back work on my displayed assembly, you'll notice something funky happened, right? This associativity didn't maintain itself, and I want to know why. Let's go back in here. Very interesting. Interesting. So not exactly too sure why that associativity was not maintained, but you can still use the sketches itself to then run this off. So for now, what I'm going to do is actually redo that sketch. There we go. And I'm going to project my curve again. Select these. Okay, finish. Nope, not sketch. Let's try that again. Goodness. What are you doing, NX? Here we go. That's what I wanted to do. We'll specify a vector, and since it's, usually normal, we'll just do that, and then, again, press OK. Go back to my displayed assembly. Let's try that again. Make this 5. Okay. So, not sure exactly why, but the associativity between these sketches and that face is no longer working, but that's all right. But at least you now know that you can just drive different features, or you can take the curves off of a different body rather than running it off of wave geometry. And this is why wave geometry linker is frankly more foolproof than just using sketches and using these reference bodies, because essentially the sketches weren't designed to update automatically, whereas the wave geometry was designed or made specifically to update when one thing is changed.
Hey, Bilal, just real quick to help you on that. When you were creating it, you were projecting the curves.
Mm-hmm.
If you would have included the curves, it would have stayed. It would have been more. It would have stayed associative, by the way, on the sketch command. Okay.
So, okay, thank you.
It happens. No big deal.
Thank you for catching that. So, including it, because I did run a test run with this. So earlier I did an inclusion, and then I just made them non-reference parts or non-reference objects, which is why I was able to maintain associativity. But for this project, it just projects it, doesn't maintain that associativity. Thank you for catching that, Brian. Now, as I was talking, or as I was saying, when I hit save, I'll be met with this dialog box, which will then allow me to then choose where I want those folders to essentially go. And I don't want it in bottom up. I want it in top down. So I'll say, all right, and I'll call this M1, and I'll hit tab, and I'll go down to here. I can click, or I can just continuously hit tab. I can just M2, and I'm just going to make sure that this is in the right folder. Let's go back to M2. Make sure you're in the right folder. Nope, you're in bottom up. I want you in top down. Going to go to M3, or label this M3. And I'm going to make sure that this is also in the appropriate folder. You don't have to do this every single time, but this is just I guess, because I was working with this and I saved this as my last default save, or that's where I just put my last save, which is why it's pulling up that particular file path. Now, that's top-down assembly, pretty simple. I can then work on these, by themselves. If I make this, where is it? I click on this and then open in a window, I just have my piece over here, and I don't have to worry about anything else. Now, if I come over here, and in my main assembly structure, just, created a sketch off of this over here. Let's say if I wanted to make a simple cylinder. Oh, there you go, simple cylinder. And extrude that. And I'll say, you know what, that's good. And now what I'm going to do is I'm going to go into my assemblies, and I can clearly do this thing, right? So I can select new component, and I'll just say, that's the object that I want to select. There we go. That's the object I want to select, and I'll say OK. And yeah, I've got model 1, and that's model 1. All is good, right? Well, the truth is, if I try and open this in a new window, and for some reason, again, NX just does not like me today because all of my points aren't showing up, but that's all right. Essentially, what would have happened had I done this is it would have pulled in this block with it. And this is something that has happened on multiple occasions, and maybe they've patched this now because it's a very common mistake to do. And perhaps because yesterday was a monthly update, so it actually might have been patched yesterday. But usually when you do this, it will bring this block in with it. So I'm just going to hit save again, and I'll just call that M4 and make sure it's in the right file path. Yep, great. Now, how do I do bottom up? Well, that's simple. I just start, creating components or adding components into this assembly. So you can just click on add component, which is not the same as new component. New component will create a new file or a new little component space for you to then model into. Add component is for if you already have things in there. So in this case, I'll say, you know what, I want M2, and I'll say, I want it somewhere right around here. There we go. And I'll hit OK. And it'll ask me, hey, this is the first component in the assembly. Do you want to fix it? I'll say yes. And so now I have my M2 fixed in there, fixed in place over here. And I can constrain to this as I please. So I'll add more components. Let's say I'll add M4 and I can select a component over here. I'll say that because, that's an appropriate way to constrain something, isn't it? And then hit OK. And of course, I have my components. And that's what bottom-up assembly is, where you can just take components and add them in without having to worry about it too much. And then, of course, that's where I would then use my constraints to then pull things in and out. Now, that's just a simple demo, and I hope that made sense. So I'm going to move on over here to our Q&A portion. Does anyone have any questions?